Welcome, this is the video lecture on exterior angles of a triangle. The learning target is for you to understand the properties of exterior angles of a triangle. Your success criteria is for you to be able to solve for missing values and angle measurements in a triangle. So our vocab, there are two types of angles inside on a triangle. There's the interior angles, which are on the inside of the triangle, and there are the exterior angles, which are on the outside of the triangle. Make sure you understand the language of both of them. Okay, interior means inside, exterior means outside. So we're going to review on how to solve for the missing interior angles of a triangle. We know that we can set up the sum of the interior angle equation, which is we add all the values on the inside of the triangle and we set them equal to 180. Okay, so 32 plus x plus 48 equals to 180. Then we could solve for x. Okay, simplify 32 plus 48 is 80. Subtract 80 to both sides, you get x equals to 100. That means the angle measurement here is 100. Now, what happens if I extend this line here? What you have here is just me extending the line, and I put an angle y here. Okay, we know that this has to be a linear pair because this makes a physical line. Right? These are two angles that are supplementary. They make a line. Okay, so we could set up the equation. 48 plus y equals to 180 because again it makes a line. Then we could solve for the angle y. So subtract 48 to both sides, you get y equals to 132. So we know that this is 132. What I would like you to notice is anything interesting about the angles here. Take a look. Let me give you a hint. Look at the 133. Do you see 132 anywhere? Well, you see that you see the 100 on here, then you see the 32 here. That is very interesting. This leads us up to our core concept. This is considered an exterior angle. It's considered an exterior angle because it's on the outside. We know that the exterior angle of a triangle is the sum, that means add, the opposite interior angles. These are both inside, right? These are both your interior and this interior. And this is the farthest away. So this is the farthest away. It's not the closest one. These are your two farthest ones away. Okay? Farthest away. Farthest away interior angles is defined by here. That's the core concept. Now, let's solve for the missing values of the exterior angle. We know that this is the exterior angle. Well, based on our equation, we could set this up. Okay? This is called the exterior angle of a triangle. Okay? We can add up the 60 plus the 40, right? Because these are your interior angles, and these are the farthest away. So I could do 60 plus 40 would give me this outside. So I know that angle E equals to 100. I'm done. There's another way you could do this. Is using the old classic equation, right? We have 60, 40, and we need to know what x is first. So you're going to set up the sum, okay? So you're going to add all the inside ones. Add all inside ones, angles, okay? So this becomes 100 plus x is equal 100 plus x equals to 180. Subtract the 100 from both sides, you get x equals to 80. So I know that this is 80. Now you could set up the linear pair, right? Okay, x, you have 80 plus e is equal to 180 because they form a line. Then you could solve for e, which is just equal to 100. Okay, either way, you still get the same answer. This requires two steps. Okay, the other one, the other way, doesn't require. It only requires one step because it uses this equation, the exterior angle of a triangle. Okay, so What I need you to do is now practice it. Pause and try it. Here's the solution. The exterior is equal to the sum of the opposite interior angles. Okay, so this is the exterior angle, this is the interior, and this is your interior, and they're on the farthest away. Okay, set up the equation. 98 plus 50 is equal to x, so you get x equals to 148. You're done. What about number 2? Well, you're still going to set up the same equation, but this time you're setting x plus 102 is equal to 148, because again, the 145 is on the exterior angle, the 102 is your interior, and your x is also an interior. Now you could solve for x. Subtract 102 to both sides, you get x equals to 43. This is 43. Okay, this makes sense because if you draw it out, 43 plus 102 should get you 145 here. That matches up. Good. So this is a very simple way of doing it by just looking at the angle measurements. Now you also have a chance to now do it, but now you have an equation, you have variables in it. But again, the setup is still the same. Okay, it is the interior, the exterior is equal to the sum of your two opposite exteriors. Okay, pause the video and give this a try. We know that the exterior is equal to the sum of the opposite interior angles. So here, your exterior, which is your 2a, is going to be equal to your interior angle, a plus 10, plus your 144 here. Combine like terms, the 10 plus 44 becomes 54. Subtract a to both sides, you get a equals to 54. Next, same thing here. This is your exterior angle. Here is your this is your interior, and this is your interior. So that's how they set up the equation. Your exterior, z plus 50, is equal to your interior plus your interior here. Now you could combine like terms. The z plus the 4z becomes 5z. You're going to subtract z to both sides to get 4z. Subtract 10 to both sides. You get 40 equals to 4x. Oh, sorry, I made a mistake. This should be z. This should be z here. This should be z here. Divide by 4 to both sides. You get z is equal to 10. Okay? There you go. That's it. That's all you need to know. Please understand the core concept, which is that the exterior angle is equal to the sum of your two interior angles, and these two interior angles have to be the farthest away. All right, there you go.